We are going to see about evaluation of definite integrals in complex analysis. We are going to deal with an example. Let us evaluate integral over c 3z minus 1 by z cube minus z dz, where c is a circle mod z equal to 2 and mod z equal to 1 by 2. Now here c is the circle mod z equal to 2 represents a circle with center 0 and radius 2. And in the second subdivision, the circle given is mod z equal to 1 by 2. So here it is a circle with center 0 and radius 1 by 2. So while evaluating the definite integral, the condition is your point should lie inside the circle. Let us first consider the function f of z equal to 3z minus 1 by z cube minus z. We must split this function into partial fractions. So in the denominator, let us take z out first. So it becomes z into z square minus 1. And then once again, for getting a linear factor, z square minus 1 can be written as z plus 1 into z minus 1. And then we use partial fractions and split the function into a by z plus b by z plus 1 plus c by z minus 1. Let us name this equation as equation number 1. Next, 3z minus 1 is equal to a into z plus 1 into z minus 1 plus b into z minus 1 plus c into z plus 1. We must calculate the values of a, b and c. So, when we put z is equal to 0, we can get the value of a as 1. And when we put z is equal to 1, we get the value of c as 1. When we put z equal to minus 1, we get the value of b as minus 2. And putting all these values a, b, c in the equation number 1, we get f of z is equal to 1 by z minus 2 by z plus 1 plus 1 by z minus 1. Now, let us evaluate the integral. Take integral over c dz throughout the above equation. And then let us use Cauchy integral formula. What is Cauchy integral formula? Integral over c f of z by z minus z naught into dz equal to 2 pi I into f of z naught. The condition is your z naught should lie inside the circle. Let us consider the first subdivision, mod z equal to 2. So mod z equal to 2 represents a circle with center 0 and radius 2. The first integrand, 1 by z dz. We must compare this equation with our Cauchy integral formula. Here f of z is equal to 1 and z naught is equal to 0. Since 0 lies inside the circle mod z equal to 2, Cauchy integral formula is applicable. So f of z is equal to 1, hence f of z naught is also equal to 1. Here z naught is equal to 0. So 2 pi I into f of z naught becomes 2 pi I into f of 0, which gives 2 pi I. So the first integrand value, integral over c, 1 by z dz becomes 2 pi I. And the second term in equation 2 was integral over c 2 by z plus 1 dz. Look at the denominator z plus 1. So compare it with Cauchy integral formula. In the denominator we should have z minus z naught. So z naught is equal to minus 1 here. So minus 1 also lies inside the circle mod z equal to 2. So 2 pi I into f of z naught becomes 2 pi I into f of minus 1. And here f of z is equal to 2. The numerator is 2. So f of z is equal to 2. So f of minus 1 is also equal to 2. Hence we will get 4 pi I. Hence the second integrand, integral over c 2 by z plus 1 dz is equal to 4 pi I. The third term in equation 2 was integral over c 1 by z minus 1 dz. Let us compare it with Cauchy integral formula. The numerator f of z is equal to 1 and in the denominator z naught is equal to 1. 1 lies inside the circle mod z equal to 2. So 2 pi I into f of z naught becomes 2 pi I into f of 1, which is equal to 2 pi I into 1, which is equal to 2 pi I. So the third integrand value is integral over c 1 by z minus 1 dz equal to 2 pi I. Let us substitute these three equations 3, 4 and 5 in equation number 2. So we will get integral over c 1 by z dz minus integral over c 2 by z plus 1 dz plus integral over c 1 by z minus 1 dz equal to 2 pi I minus 4 pi I plus 2 pi I, and we get the answer as 0. So the answer for the first subdivision is 0. The second subdivision is mod z is equal to 1 by 2. In this, the circle is with center at 0 and radius 1 by 2. The same integrand values. Let us first consider integral over C 1 by z dz. So when comparing it with Cauchy integral formula, z0 is equal to 0 and 0 lies inside the circle mod z equal to 1 by 2. So f of z is equal to 1, which implies f of z0 is equal to f of 0 equal to 1. So 2 pi I into f of z0 becomes 2 pi I into f of 0, which is equal to 2 pi I. So the first integrand value is 2 pi I. Let us consider the second integrand, integral over C 2 by z plus 1 into dz. Here f of z is equal to 2 and z0 is equal to minus 1. But our circle is a circle with center 0 and radius 1 by 2. Minus 1 lies outside the circle. So 2 pi I into f of minus 1 becomes 0 and the second integrand value is 0. The third term, integral over C 1 by z minus 1. Comparing it with Cauchy integral formula, f of z is equal to 1 and z0 is equal to 1. Here the circle is mod z equal to 1 by 2. The circle is with the center 1 by 2. So here 1 lies outside the circle. So once again 2 pi I into f of z0 is equal to 2 pi I into f of minus 1, which is equal to 0. The third integrand value becomes 0. So finally integral over C f of z dz will be equal to 2 pi I minus 0 plus 0, which yields the answer as 2 pi I. Thank you.